Okay, so here's our third video on graphing quadratic functions or parabolas, and now I've got a little bit more complicated equation. This is basically about as bad as they can get. So what I've written it on this side, because let's start with the talking to the equation or listening to the equation. So again, I'm sort of thinking of what sort of y's come out when I put in different x's, but I don't want to go through this tedious process. I just want to think more in general. So what I do is I look at this part here where the x goes in, and I say to myself, no matter what x goes in there, x minus 4 squared is always greater than or equal to 0, right? Because I could put in x's, like I could put in 0, and then, sorry, let's put in x minus 4 squared to see what that is. So 0 minus 4 squared is minus 4 squared, which is 16. So you see, no matter what I put in here, I always get a positive value out. There's one value I can put in to actually get out 0, which is 4. If I put in 4, then I get 0 squared, which is 0. So this part is always greater than or equal to 0. So what I have is y is equal to minus 2 times something, some number that's greater than or equal to 0. And then I add 3. So what happens when you take minus 2 and multiply it by actually 0? You get 0, and then you add 3. So y equals 3 when this is 0, which means x equals 4. Okay, so that's going to be my vertex, you'll see. And then from there, y equals minus 2. Well, the only other choices we have other than 0 are something greater than 0, so it would be positive. For example, positive 1. And then when we multiply that by minus 2, it will become negative. So I will have a negative number plus 3. So the result will be less than 3. So y is always less than or equal to 3. Because as this number becomes bigger than 0, we multiply it by minus 2, which makes it negative, so then we end up subtracting it from 3. So now we know we basically have an upside down parabola, which we can tell right here by this negative sign. So this means upside down. Okay. As before, we know that the vertex occurs when we plug in the value that makes this 0. So that's the x-coordinate of our vertex is 4, because 4 minus 4 is 0. And the y-coordinate is just what's left right here, because when we do plug in this 4 and this becomes 0, it wipes out this whole part of the equation, because minus 2 times 0 is just 0. So we're just left with what's right here. So then we go over here, and let's see, we want to be at plus 4, 1, 2, 3, 4, and plus 3, 1, 2, 3. So here we are, sort of my new center of the parabola. So I just make a bullseye right where my vertex is going to be. Now I know that it opens down, and the fact that there's a number in front of here means that something a little bit different is going to happen. So when I move 1 away from the vertex, for example, putting in x equals 5, 5 minus 4 is 1. So it's the same result as just squaring that 1. So 1 over, I square the 1, I get 1, but now I'm going to multiply it by minus 2. So instead of over 1 and down 1, I'm over 1 and down 2. So 1 squared is 1, and then I double it and go down. 2 squared would normally coincide with 4. Up here, but it's negative, so it's down, and it's doubled, so it's actually not down 4, it's down 8. So over 2 will be down 8. So 1, 2, 3 to get here, 4, 5, 6, 7, 8. So right here is my second point. Okay, so here, 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 and a little bit rounded around the vertex, and like that. Now the axis of symmetry always goes straight through the vertex, so I can just duplicate these points, go straight across an equal distance on the other side. So this is 1 from the axis of symmetry, so 1 on the other side. This is 1, 2, so 1, 2, this point is right here, and away we go like that. Okay, awesome. Now, we'll just quickly go over how this thinking about the equation relates to a rather more thoughtless process, which is just noting that this is with the x, so it's a horizontal shift. and it's always in the opposite, so it's plus 4. And then this, tagged on at the very end, is a vertical shift, and it's always the same, so it's up 3. I mean, the same sign as what here. And then this is multiplying our function, so it changes its shape, makes it, stretches it vertically, and flips it upside down. All right, there we go.